Okay, we were on question 5 when that last video ran out. And we were just about to find our acceleration because we have a VF, a VI, and a delta t. So we can find A. So A is equal to VF minus VI over delta t. VF is 0. So A is equal to negative 30 meters per second over 5 seconds. So A is equal to negative 6 meters per second squared, where here the negative means slowing down. Well, that's no surprise. You stepped on the brakes. Okay, so now that we have our A, we go back and see what the question wanted, and it wanted to know the force. So it doesn't say anything about friction. And really, the friction comes into play with the brakes. So the only force when we do sum of the forces in the x direction is equal to max. The only force is the braking force, and that's equal to max. Now, I could put a negative on it because I know it's acting in the opposite direction of motion, but even if I don't, it's going to work out that way. When it's my unknown, it's okay if you don't put the negative in, because watch what happens. So the braking force is equal to m, which is 15,000 kilograms, times a, which is negative 6 meters per second squared. And so the braking force here ends up being negative 9,000 newtons, where the negative means opposite motion, which, if you actually want to stop, the braking force should be opposite motion. Okay? All right, number 6. Number 6 says an object which weighs. Okay, so we're back to the weigh again. So if I draw my object, it weighs, what was it? 150 newtons. So Fg is equal to 150 newtons. So over here on the side, I can do Fg divided by g. So I can do 150 newtons divided by 9.81 meters per second squared. And I can find that my mass is equal to, it is 150, right? No, it's 15. Sorry, there's a decimal there. Is equal to 1.5291 kilograms. 1.5291 kilograms. All right. So an object that weighs 15 newtons is thrown forward on the ice with a speed of 20 meters per second. So it's given a speed, VI, of 20 meters per second. And I'm drawing that out here so you don't think it's a force there. And after 5 seconds, it only has half of its original speed. So VF then is 10 meters per second, and delta T is after 5 seconds? Yeah, 5 seconds. So from this we can find our A. A equals VF minus VI over delta T. So A equals 10 meters per second minus 20 meters per second over 5 seconds. Negative 10 on the top divided by 5. Our A is negative 2 meters per second squared. Opposite motion again. Okay, so it's slowing the object down. So then the question says, find the coefficient of friction between the object and the ice. So it says it's thrown forward on the ice. It's like a curling stone, and when you release it, it has some initial velocity. But there's no forward force once you release it. You're not sliding down the ice behind it, still pushing it. Once you've let it go, the only force in the x direction that's acting is friction acting back. Okay? And this time it wants the coefficient, I believe. Find the coefficient. So this time we can start with our sum of the forces in the y direction. It's not moving in the y, so it'll be Fn minus Fg equals 0. So Fn is going to equal Fg, and we were told in the question Fn was 15 newtons. I keep wanting to make it 150. Then with that, we can also do some of the forces in the x direction. And in the x direction, we have friction acting backward, and that's equal to max. And so friction is going to be 1.5291 kilograms times this negative 2 meters per second squared. And so we will get a frictional force of negative 3.0581 newtons. And the negative just means opposite motion. Okay, question wanted coefficient. And so we have Fn and we have FFR. So now we can do FFR is equal to mu Fn. So mu is equal to friction divided by Fn. And this one, you don't need to put your directions in. These are perpendicular to each other, so this negative means absolutely nothing. So it's going to be 3.0581 newtons divided by 150 newtons. And so mu ends up equaling, I did 150 again, 15. I was going to say that's going to be really tiny. 0.20387, and remember mu has no units. All right, and the last question that you had, number 7, says a box which weighs again. So again, giving you the FG. So an object which weighs 10 newtons is pushed across a level floor by a person who exerts a force of 5 newtons parallel to the floor. So your F here is 5 newtons. Of course, there's the normal force going up. Coefficient of friction is 0.2. It's going backward. So mu is 0.2. And the question wants to know what is its acceleration. So again, you might want to find your m. M is equal to Fg over g. 10 newtons divided by 9.81 meters per second squared. So your m is 1.0194 kilograms. 1.0194 kgs. All right, because they gave us a coefficient, we need a normal, so sum of the forces in the y. This object is not moving in the y direction, so MAY is 0. We have Fn going up, Fg going down, so it goes in as a negative, equals 0. So Fn equals Fg equals 10 newtons. And I know that's a pain. I promise that in the next video, we're going to spice it up, and so you'll understand why I was doing this. Now we can find friction because it's equal to mu Fn, and we have both mu and Fn. So friction is 0.2 times 10 newtons, so friction is 2 newtons. And then you do sum of the forces in the x direction. And we're looking for our acceleration, so you have the force you're pushing forward with minus friction is equal to max, divide both sides by m. So ax is equal to the force you were pushing with was 5 newtons minus friction, which you just found, 10 newtons, divided by this 1.0194 kilograms. On the top is 3, on the bottom is something slightly bigger than 1. So your acceleration should be 2.943 meters per second squared. Okay? So there are your 7 practice questions.